Learning can be defined as a process that leads to change which occurs as a result of experience and increases the potential for improved performance and future learning. In learning, the knowledge of an individual has its own influence. The prior knowledge lays the groundwork for new learning. It is true that if students' prior knowledge has gaps and insufficiencies, it may not adequately support new knowledge. Moreover, if prior knowledge is applied in the wrong context, it may lead students to make faulty assumptions or draw inappropriate parallels. In addition, inaccurate prior knowledge, some of which can be surprisingly difficult to correct, can both distort students' understanding and interfere with incoming information. This lesson will give a brief outline about the significance of prior knowledge and the need of knowledge organization, along with the strategies to reveal and enhance knowledge organizations. Students come with knowledge, beliefs and attitudes gained through education and through their daily life. As students bring this knowledge to bear in the classrooms, it influences how they filter and interpret what they are learning. If students' prior knowledge is robust and accurate and activated at the appropriate time, it provides a strong foundation for building new knowledge. However, when knowledge is inert, insufficient for the task, activated inappropriately or inaccurate, it can interfere with or impede new learning. Students naturally make connections between pieces of knowledge. When those connections form knowledge structures that are accurately and meaningfully organized, students are better able to retrieve and apply their knowledge effectively and efficiently. In contrast, when knowledge is connected in inaccurate or random ways, students can fail to retrieve or apply it appropriately. How does students' prior knowledge affect their learning? As we teach, we often try to enhance our students' understanding of the course content by connecting it to their knowledge and experiences from earlier in the same course, from previous courses or from everyday life. Students do not come into our courses as blank slates, but rather with knowledge gained in other courses and through daily life. This knowledge consists of an amalgam of facts, concepts, models, perceptions, beliefs, values and attitudes, some of which are accurate, complete and appropriate for the context, some of which are inaccurate, insufficient for the learning requirements of the course or simply inappropriate for the context. As students bring this knowledge to bear in the classrooms, it influences how they filter and interpret incoming information. Ideally, students build on a foundation of robust and accurate prior knowledge, forging links between previously acquired and new knowledge that help them construct increasingly complex and robust knowledge structures. However, students may not make connections to relevant prior knowledge spontaneously. If they do not draw on relevant prior knowledge, in other words, if that knowledge is inactive, it may not facilitate the integration of new knowledge. Moreover, if students' prior knowledge is insufficient for a task or learning situation, it may fail to support new knowledge, whereas if it is inappropriate for the context or inaccurate, it may actively distort or impede new learning. What is the impact of prior knowledge? Students connect what they learn to what they already know, interpreting incoming information and even sensory perception through the lens of their existing knowledge, beliefs and assumptions. In fact, there is widespread agreement among researchers that students must connect new knowledge to previous knowledge in order to learn. However, the extent to which students are able to draw on prior knowledge to effectively construct new knowledge depends on the nature of their prior knowledge as well as the instructor's ability to harness it. In the following sections, we discuss research that investigates the effect of various kinds of prior knowledge on student learning and explore its implications for teaching. When students can connect what they are learning to accurate and relevant prior knowledge, they learn and retain more. In essence, new knowledge sticks better when it has prior knowledge to stick to. What are the various methods to gauge the extent and nature of students' prior knowledge? Let me see some of them. Talk to colleagues, administer a diagnostic assessment, have students assess their own prior knowledge, use brainstorming to reveal prior knowledge, assign a concept map activity, look for patterns of error in student work. Now, let me see different methods to activate accurate prior knowledge. Use exercises to generate students' prior knowledge. Explicitly link new material to knowledge from previous courses. Explicitly link new material to prior knowledge from your own course. Use analogies and examples that connect to students' everyday knowledge. Ask students to reason on the basis of relevant prior knowledge. How does the way students organize knowledge affect their learning? When we talk about the way people organize their knowledge, or for the sake of simplicity their knowledge organizations, we are not talking about particular pieces of knowledge, but rather how these pieces are arranged and connected in an individual's mind. Knowledge can be organized in ways that either do or do not facilitate learning, performance and retention. As an illustration, consider two students who are asked to identify the date when the British defeated the Spanish Armada. The first student tells us that the battle happened in 1588 and the second says that he cannot remember the precise date, but thinks it must be around 1590. Given that 1588 is the correct answer for this historical date, the first student appears to have more accurate knowledge. Suppose, however, that we probe the students further and ask how they arrived at their answers. The first student then says that he memorized the correct date from a book. In contrast, the second student says that he based his answer on his knowledge that the British colonized Virginia just after 1600 and on the inference that the British would not dare organize massive overseas voyages for colonization until navigation was considered safe. Figuring that it took about 10 years for maritime traffic to be properly organized, he arrived at his answer of 1590. These students' follow up answers reveal knowledge organizations of different quality. The first student has learned an isolated fact about the Spanish Armada, apparently unconnected in his mind to any related historical knowledge. In contrast, the second student seems to have organized his knowledge in a much more interconnected and causal way that enabled him to reason about the situation in order to answer the question. The first student's parents' knowledge organization would likely not offer much support for future learning, whereas the second student's knowledge organization would provide a more robust foundation for subsequent learning. Now, let me see about knowledge organization. As a starting point for understanding how knowledge organizations differ and the consequences of those differences, it helps to consider how knowledge organizations develop. This is addressed in the section below. The way people organize their knowledge tends to vary as a function of their experience, the nature of their knowledge and the role that knowledge plays in their lives. Now, let me see what are the various strategies to reveal and enhance knowledge organizations. Number 1, create a concept map to analyze your own knowledge organization. One way to make your own knowledge organization apparent to yourself is to create your own concept map. Concept mapping is a technique that helps people represent their knowledge organizations visually. Once you have produced your own concept map, the central organizing principles and key features you use should be easier for you to recognize. Analyze tasks to identify the most appropriate knowledge organization. It can be helpful to analyze the tasks assigned to determine what kind of knowledge organization would best facilitate learning and performance. Then you might consider providing your students with a skeletal outline or template for organizing their knowledge. Number 3, provide students with the organizational structure. Do not assume that your students, especially those who are new to the content area, will see the logical organization of the material you are presenting. They may not see basic relationships or category structures. Therefore, providing students with a view of the big picture that presents the key concepts or topics and highlights their interrelationships can help students see how the pieces fit together. Then explicitly share the organization of each lecture, lab or discussion. Because students' knowledge organization guides their retrieval and use of information, it is especially beneficial to help students create a useful organization as they are learning. To this end, providing an outline, agenda or visual representation of each lecture, lab or discussion session can give students a framework for organizing the information they are about to learn. Be sure that the organizational structure you provide captures the critical concepts or principles around which you want students to organize the information from the class. For example, an agenda that includes headings such as introduction, lecture, discussion and recap is considerably less useful than an agenda entitled 3 rules to guide ethnographic fieldwork, the reasons for these rules and a discussion of their limitations. Fifth strategy is use contrasting and boundary cases to highlight organizing features. To help students develop more sophisticated and nuanced ways of organizing knowledge, it can be useful to present contrasting cases or 2 items that share many features but differ in critical ways. A simple example would be a comparison of shark and dolphin, which have many similarities but represent different classes of animals. Presenting 2 such cases together makes the differing features more salient and helps students develop deeper and more finely articulated knowledge structures. For example, instead of organizing animals superficially by habitat, they begin to organize them according to their other features: vertebrate versus non-vertebrate, warm blooded versus cold blooded, live birds versus egg laying and so forth. Number 6, explicitly highlight deep features. In order to help students develop more meaningful and less superficial knowledge organizations, highlight the deep features of problems, designs, theories and examples. One way to do this is to provide examples of problems that share deep features but differ superficially, or examples of problems that are superficially similar but operate on different structural principles. The next strategy is make connections among concepts explicit. As you introduce a new concept or design, theory, example or problem, explicitly connect it to other students have learned. For example, you may remember encountering a similar situation in the case study we read last week. The connections you draw do not always have to be similarities. They can also be contrasts or discrepancies, as like what makes this artist's work so different from other abstract expressionists. In addition to pointing out these connections yourself, it is important to ask questions that require students to make their connections themselves. For example, where we have seen this theoretical orientation before, what aspects of this case are similar to or different from the labor management case we discussed yesterday. The eighth strategy is encourage students to work with multiple organizing structures. To enable more flexible application of knowledge, students need to develop multiple knowledge organizations that they can draw on as appropriate. One way to help students develop multiple representations is to ask them to categorize a set of items according to more than one organizational schema. For example, you might ask students to classify plants first on the basis of their evolutionary histories and then on the basis of native habitat. This classification task could then be followed by questions that illuminate the implications of organizing knowledge one way or the other. Giving students practice organizing their knowledge according to alternative schemata or hierarchies helps them see that different organizations serve different purposes and thus builds more robust and flexible knowledge organization. The next strategy is ask students to draw a concept map to expose their knowledge organizations. Asking students to create concept maps gives you a window not only into how much students know about a particular subject, but also how they are organizing and connecting their knowledge. Concept maps are a visual representation of a knowledge domain. A concept mapping activity can be used at the beginning of a course to reveal students' prior knowledge organization and then in an ongoing manner to monitor how that organization changes with time and experience. Concept maps, whether graded or ungraded, can help you diagnose problems in students' knowledge organization. For example, if they have miscategorized pieces of knowledge, inappropriately linked unrelated concepts, or failed to connect related concepts, or assigned an item to a superordinate position that belongs in a subordinate position, and so on. The next is use a sorting task to expose students' knowledge organizations. Another way to expose students' knowledge organizations is to ask them to sort different problems, concepts or situations into categories. This method reveals how students organize their knowledge without requiring them to identify their sorting criteria explicitly. One example of a sorting task is presenting students with a set of problems that have some superficial and some deep features in common and asking them to group the problems according to similarities. If students group projects on the basis of superficial similarities, it is an indication that they do not recognize the deep features that would help them develop more meaningful and flexible knowledge organization. The another strategy is monitor students' work for problems in their knowledge organization. One way to detect problems in students' organization of knowledge is to pay attention to the patterns of mistakes they make in the work for your course. For example, do students frequently mix up two conceptual categories such as confusing theories and methodologies are force and acceleration problems. Do they apply a formula, strategy or solution in a consistently inappropriate way? If so, it is possible that students are making inappropriate connections or categorizations that are impeding their learning and performance. In this module, we have examined the critical role of prior knowledge in laying the groundwork for new learning. We have also reviewed to the fact that it is not just what you know, but how you organize what you know that influences learning and performance. Thank you.